here we have a rational equation, which is an equation that contains one or more rational expressions. Because we have a variable in the denominator, the first step in solving this rational equation is to list any restrictions that exist. In other words, numbers that make a denominator equal to 0 can never be solutions. We cannot let y equal 0 because we would have our division by 0 error, which makes this undefined. So y cannot be 0, nor if we set this equal to 0 and solve for y, we would find if y was 2. 2 minus 2 would give us a 0. So our two restricted values are 0 and 2. Next, we move on to solving this by clearing the equation of fractions. And to do that, we'll multiply both sides by the least common multiple of the denominators. The only factors in the denominator are y and y minus 2, so that will form our least common multiple. I'm going to multiply both sides of the equation by that least common multiple. And here on the right side, by multiplying both sides of the equation, we have maintained equality. Here on the left, when you go back to simplify, this product has a denominator of 1. We're multiplying these three factors over this one factor, and the y over y is equal to 1, leaving us with a distributive property to simplify this. We have y times 8, 8y, and y times 8 times negative 2 for negative 16. On the right side, we're going to distribute this over the two terms here. So we will end up with a y times y minus 2 times the first term or rational expression plus 1 times that term. So we cleared our first distributive. The left side is fine, but on the right side, we have three things multiplied together. The first two have a denominator of 1, and before we multiply, notice we have a common factor of y minus 2, which is eliminating the fraction or the rational expression, the whole idea of multiplying by the least common multiple, which leaves a y times 1 times 2, or 2y. Moving then to the next multiplication, we will use distributive property again. Y times y is y squared, y times 2, 1 being negative, 1 being positive, a negative 2y. Simplifying on the right side by combining like terms, the 2y minus 2y cancel one another out. We have the basis of a quadratic equation, and to solve it, we need it in standard form. So I'm going to bring these two terms over to the right so that it is equal to 0. That means I'm subtracting an 8y from each side and adding a 16 to both sides. Now, to solve this, we'll factor, which it factors into y minus 4 times y minus 4. It's a perfect square trinomial. Using the principle of zero products, we'll set these factors equal to 0. Since they're both the same, we will get the same value. And then solving for our variable, we get y is equal to 4. This is a possible solution. It could be rejected if it's on our restricted list. It is not. 4 is not one of our restricted values. And the only thing left then is to check by plugging it into the equation to verify that it does give us a true result. And doing that, we would have 8 over 4 see if that's equivalent to 2 over, replacing y with the value we believe to be the solution gives us the following. Well, 8 over 4 is 2. Simplifying the denominator, 4 minus 2 is 2. Simplifying that rational expression is 1 plus 1, and 1 plus 1 is 2. So we have a true result. That means we can accept y minus 4 as our solution to this rational equation.